I must express deepest gratitude to the host. I'm seeing her for last 3 years, very painstakingly and consistently hosting this Kerala Startup Mission in an exemplary way. And a lot of thanks to Kerala Startup Mission. We work very closely with them, Hitachi, and we are very proud to be associated. Okay, so today I am going to talk about a little bit about systems. Whenever we build system, now the startup ecosystem itself is a fantastic system. Now, whenever we build a smart system, and you saw a lot of that, you heard some 3D printing of the houses, you heard about generative AI yesterday. So there are some fantastic things that's happening in India today. Now, as a startup company, whenever you build a system, how do you approach it in a methodical way? That's what we're going to talk about. So while the presentation comes up, let me share a few things about what we, Hitachi, do about the systems. Hitachi has 3 main pillars today. We focus on green energy, a lot of systems like hydrogen-based, electric vehicle, charging, the batteries and stuff like that, the wind power turbines. So Hitachi is an $80 billion company, and out of that, $5 billion we do on research almost every year, and out of that $5 billion, a significant portion goes to energy research. The next alternative sources of energy, we focus on that. We, Hitachi, develop a lot of connected systems, mobility, railways. Japan's bullet train, Shinkansen N9000, it's Hitachi powers that, we develop that. And finally, we do a lot of digital systems. So we will focus a little bit on digital today. Okay, so let's look at two things. We'll have last 5 minutes for Q&A. So whenever we develop any new interesting smart system, we need a strategy and we need, of course, the implementation. Now, on the strategy, there is a very easy way you can remember it. We can call it HUM, H-U-M, and this is human-centered, user-centric, and meet in the middle. And we'll talk about that in a moment. But whatever system you build, whether you build it for a housing or you build it for a smart medical system, at the end of the day, a very important thing that you have got to remember that whom are you developing it for? So let us look at this strategy. The strategy can be top-down, it can be bottom-up. Now, if you are working on a very interesting technology like quantum computing, or for example, artificial intelligence, or next alternative sources of green energy, you may think that your bottom-up approach is awesome. You know your stuff, you want to bring it to the table for the users. But the question is, whom are you building it for? What are the use cases? Are you going to make money out of it? Is there enough business in there? Do you have the ecosystem support? Do you have access to capital? Do you have access to resources who can actually help you build the system? Do you have some credibility there? So all these things are very important. And hence, ultimately though, we have to look at top-down approach. Look at what are the business problems that you are trying to solve. So at the end of the day, you have got to do meet in the middle. And that's where, now, 3 things. Whenever you build a smart systems, you have got to do Very important. You have to imagine. You have to come up with something new, something different. Imagination is extremely important. I cannot tell you, all of you out here, you can be the best technology gurus in the world, but at the end of the day, you have got to be an imaginator. You have to come up, imagine new solutions in an innovative way. And that's probably one thing artificial intelligence will not be able to do for many years going forward. So imagine. Second thing is empathize. Empathize is also known in many ways design thinking. How do you go and put yourself in the shoes of the user who would be using it? For example, in Shinkansen bullet train system that Hitachi developed, it has a very interesting problem. When it goes round the bends, the train starts tilting to one side, and all the people, passengers in the train, they also start tilting along with the train. So how do you go and give them the right feel that they are also not tilting like this, but the platform itself changes? It adjusts to that centrifugal force. That's empathy. You understand, try to feel the pain of the user that they are also tilting when a 200, 300 kilometer train is moving. How do you go and make them, feel better? This feeling better, understanding the problem of the user, that's empathy. It requires a lot of research. It may seem very simple thing. If you can solve that one problem of empathy with the user, maybe your startup is going to fly up. And that is very important. And the third thing is iterate. Whenever you build a system, you have got to keep iterating with the end users, the intended users, as many times as possible, as fast as possible. Whenever you build a little bit of a system, now there are two approaches you can take. You can take the SAP approach, the German company approach. You build the best system in the world and then you go and take it to the system, take it to your users. Or you can take the Microsoft approach. You build something exciting, share it with your users, let them go and test it out, let them go and give the feedback, and you keep improving. So your strategy is very important. Now, if you are building a healthcare system or a space tech mission, you have to do it solidly, like the way the German companies do, the Japanese companies do. You have to really, really do it very well before going and taking out a half-baked system out there. But if you are building, for example, a retail system, or for example, a system where you need very quick feedbacks, you need iteration. Now comes the second part of the thing, that is the implementation. In implementation, it's very important that you start with the use cases. Use cases are fundamental to any startup initiatives. You have to know your user, and we will talk about that in a moment. The second thing is the system design. This is where I work with many young people, and I find that the system design skills are missing today. You have got to go and design your system carefully. I will talk to that in a moment. Third is the embedded intelligence. If you are building a system and it is not smart, probably you are out of tune with the market. You have got to think about the AI, the artificial intelligence, the next generation technology. What are you bringing into that system? And the fourth is a very important thing, rendition. Rendition means how do you visualize, how do you, the look and feel, the touch and feel of the system. That's what you have got to focus on. Okay, now let's look at the use cases part of it. Who, what value, how, these three important questions. So let us take a very simple example. Let us take an example of this thing. Suppose you are building a smart city system. You have got to first do who are the users, who would be using. Now, if you look at this system, there are residents, there are visitors, there are municipalities, and for example, there are administrators, the guy who are operating the system. If you go and chart them out on four corners and look at the value of the system, that is very important. If you don't go and do the use cases, the value proposition, and their interactions right in the beginning, you will have deep trouble later on. Once you are done with these use cases, the next best thing that you can do is to start. So now you have defined the boundary of your smart city system. Now, for example, you are going into the one level deeper. You are trying to decompose the system into your major components, what you would be building. For example, for a smart city system, you have amenities management, visitor management. These are, say, the four important components. What components you're going to build? What is the name of the component? It depends upon you. You look at what is important, what is at the core, what is the core value prop of your system, and accordingly you go and you build that up. Now, these two things, let me give you a sample of a use case. Now, very often people they confuse between the use case and the business case. Use case is all about who is using it, how they are using it. But before doing how they are using it, you have got to go and understand what was the precondition and what is after the use, what would be the post condition. This is a classic way of writing a use case. You start with the precondition, then you talk about the interaction your users are having with the system, and then you talk about the post condition. What does the system leaves you there? A very important thing. Business case, though, is something more intricate. Based on these interactions, there is certain value that is flowing between the user and the system. Can you monetize the value? Is your user ready to pay for that interaction? Is your user ready to pay for that use case? That is what your very important component to the business case. So once you are done with these use cases, let us go back, and once you are done with this smart city component, like you break up your system into some principal components, you understand the interactions, you understand what are the key things you're going to build into it. The third thing that you have got to look at is what is the smartness of the system? What is the intelligence that you are building to the system? Is it going to be artificial intelligence driven? Are there going to be analytics here? How can you go and have the system go to the very next level using intelligent reporting, using intelligent interaction, and stuff like that? So a system can be broken up into subsystem components. Okay, now comes the last part. This is where the bread and butter is. This is where many venture capitalists, angel investors, they're looking at. They are not looking at you just to build another system. But if the system has that smartness, which means you have the right people who can build the system, which means that you are doing something, out of the art, people are very interested in you. Immediately they look at you and say, wow, wait a minute. These guys are really intelligent. They are going to go and make it happen in a completely different way. The interaction of the system and the users. For example, rendition, which is the interface of the system to the human users. If you can go and build in a speech interface, speech processing, or for example, a computer vision recognition, or for example, touch and smell, that kind of sensor-based system, immediately people are very, very interested. They say that, look, you guys have a lot of interesting things to offer. You have a skill that you are bringing to the table which others do not. Are you going and making your system a OT/IT, something that we Hitachi are focusing big time on, meaning operational technology, physical, mechanical, physical systems, and cyber systems? Are you going to go make a cross between them, called as cyber physical devices or the cyber physical system? If you are making something like that, I'm very interested. You heard that smart printing, right? It's a very, very interesting thing. You are printing all these houses, and inside those houses, while building it up, while printing it, can you go and start sprinkling in the sensors, embedding it with certain touch, feel, see kind of cameras and sensors? The moment you do that, your system now is value added. It's like a completely different game. Now your 3D home can see, they can talk, they can hear, you can interact. It is now completely internet enabled, IoT enabled. If you are talking about, for example, a simple ECG machine, and the ECG machine can understand who you are, immediately the value is, it has been value added. That smartness of the system. My final thought today is the system blueprint. So your final end product, you're a startup company, your final end product, now there are three things that you need. You need a view of the system from the top, from the side, from the view, just like a mechanical system, as well as how does it work? And a duck that quacks like a duck must be a duck. So your form, your function, all these things have to be visible, has to be understood. So you have got to go and create those diagrams to make people understand what your system does. When you are going and pitching it to your venture capital or angel, second round, third round of financing, you have got to go and make your system, look and feel like the way they would use it. The second thing that is important is the explainability. Can you go and explain the working of the system inside? How do the algorithms work? How do the interactions happen? That is the second thing. And third thing, that you must pass the test of evolution. Can your system is it expandable? Is it compatible? Is it something that is transformable? It is like Franz Kafka's Metamorphosis. Can you go and have the system metamorphose from system A to system B with minimal changes, minimum interventions? So this is the third thing. Okay, so I have shared with you something maybe very useful for you. How, when you go and build up a system, when you're a startup company, what are the key considerations that you should look at? Of course, each one of them, they go deep into it. And we, Hitachi, has earlier, with Kerala Startup Mission, we have sponsored agricultural and smart finance systems. We put out prize for that. Probably in the years going forward, we'll do it again. But when your results come in, when your submission comes in, these are the key things that we are looking for. Not just the results, but the way you approach the problem and the way you document the problem, the way you explain the problem, its workings. We'd be looking for it keenly. Thank you very much.